Okay, let's start our session. The next topic, magnetic effect of electric current. Magnetic effect of electric current is that magnetic fields, magnetic fields due to electric current. Magnetic field due to electric current. As previously we discussed, when a current is passing through a conducting wire, a current carrying conductor, a magnetic field is created. A magnetic field is created. So that magnetic field is created because of one of the effect of electric current. So we discussed the Oersted experiment, magnetic flux density, magnetic field lines, how we know the direction of magnetic field. So magnetic field line properties also we discuss. Now magnetic field due to current carrying wires or due to current. So current carrying current carrying conductor or wire produce or create a magnetic field. Produces or creates a magnetic field. So we can understand the magnetic field produced by current carrying conductor in three cases, right? And also know in which direction the magnetic field is formed, in which direction the magnetic field lines are moved, or the magnetic field lines are formed. So whatever we discuss through straight line. Magnetic field due to magnetic field due to straight current carrying conductor to straight wire magnetic field due to straight wire carrying current. The second one is magnetic field due to circular wire or coil or loop. Circular wire or coil or loop carrying current. Then other one is magnetic field due to a solenoid. Magnetic field due to a solenoid. So long coil of wire due to long coil of a wire. Long coil of wire carrying current. So these are the three magnetic field patterns or magnetic field. So we can study now magnetic field formed by a straight wire carrying current, circular wire or a coil or a loop carrying current, then a solenoid current carrying current. So let us discuss this. As we know, by the Oersted experiment. By the Oersted experiment, we know that when a current is passing through a current carrying conductor or the wire, a magnetic field is formed. That is called as magnetic effect of electric current. Magnetic field of electric current. So, and also we discussed that how to draw the magnetic field lines. So, that is based on the deflection of magnetic compass. Then it shows magnetic field lines. So, let us discuss one by one. A straight conductor carrying conductor. Magnetic field pattern or magnetic field due to straight current carrying conductor. So, let us discuss. Magnetic field due to straight wire carrying conductor. So, with a simple electric circuit we have taken now. So, here we place a magnetic compass. So, this is a current carrying straight wire, and this is the direction of electric current. So, in which direction the magnetic field is created? Let us understand. Take a wooden plank and make a hole as shown in the figure. So, simply right? This is a current carrying conductor. So, straight wire. Okay, take it as straight wire. When electric current is passed through, current carrying wire, magnetic field is formed. Then, for example, here with help of stand, when we hold with help of a dart stand, so when we pass through current wire, then we can place a magnetic compass. So simply this diagram will change like this, for example. On a table, or simply we can take like this only. We take like this. This is the current carrying conductor. Magnetic field. Now, so AB is the current carrying wire, straight wire. Let us assume with help of a wire. So, like this, the wire is connected. The conducting wire is straight. The conducting wire is straight. So whenever we give some connection with the battery, so like this. So when we place the magnetic compass, right? Then will we arrange the magnetic compass like that? Let us know in which direction the magnetic field is formed. So magnetic field is formed because of the magnetic effect of electric current, right? The magnetic field lines around a straight conducting wire carrying conductor are concentric circles whose centers lie on the wire. So in case of straight wire carrying current, the magnetic field lines means the magnetic field is formed around the wire. So the circle means the magnetic field is formed as a concentric circles. Concentric circles means the center of the circle is same. Center is same for all circles. So this is the center. The center is on the current carrying wire. So this is the center. Around the center, magnetic field is formed as a circles. The magnetic field is formed as a circles. Right? So when a current is carrying straight current carrying wire, so the magnetic field is formed as a concentric circle. So this is the center. For this circuit, this is the center. For this circuit, this is the center. For this circuit, also this is the center. For this circuit, also for this circuit. So all the circuits having only one center. The center is on the current carrying conductor. So when a current is flowing, when a current is passed through straight wire, or current carrying conductor, straight current carrying conductor, the magnetic field is formed around the wire as a concentric circles. Okay? In circles are formed. Then in which direction? This magnetic field is formed? In which direction the magnetic field is formed? To understand, we have to use right hand thumb rule. We have to use the right hand thumb rule. So if it is a current carrying wire, a straight current carrying wire, the direction of the thumb explains about the direction of electric current. So here this is the direction of electric current. Means bottom to top, down to up, bottom to top. In which direction the magnetic field lines are formed? In which direction the magnetic field is formed? So imagine that if we hold the object like this. So this pen acts as a current carrying conductor, straight current carrying conductor. The thumb denotes the direction of electric current. Then the fingers are nothing but the direction of magnetic field. the direction of magnetic field. So, in which direction the magnetic field is formed? Around the thumb. Around the thumb. So, if you take it like this, then the magnetic field lines are formed around the current carrying wire by concentric circles. As a concentric circles. In which direction? Clockwise direction or anti-clockwise direction. So this is the direction and these are the circles, means magnetic field line. Magnetic field is formed around the straight wire. In which direction? Anti-clockwise direction. Anti-clockwise direction. So the current carrying from this. So here to here. Here to here means bottom to top, down to up. Then this is the magnetic field direction. This is the magnetic field direction. So if the current is carrying upward direction, if the current carrying upward direction, then the magnetic field is formed around the conductor in anti-clockwise direction. Anti-clockwise direction. Similarly, if the current carrying is like this, the thumb denotes the direction of electric current. Then the fingers around the pen, nothing but the current carrying wire, is the clockwise direction. The clockwise direction. In this case, if the current is carrying downward direction, then the magnetic field, is formed around the conductor in clockwise direction. So we can understand this magnetic field formed by or produced by a straight wire carry current by using right hand thumb rule. The direction of thumb gives the direction of current. The closed fingers denote the magnetic field. So that is. So direction, upward direction, then the magnetic field is formed around the current carrying wire. So if the direction is like this, then what will happen? The fingers are the rounded fingers are denote the magnetic field. This right hand thumb rule is also. So in case of right hand thumb rule, so in case of right hand thumb rule, the right thumb denotes the direction and the fingers are denote the direction of magnetic field, or in which direction the magnetic field is formed. So in this, thumb denotes direction of current. Then the closed fingers are denotes the magnetic field. So straight line. So from the direction of electric current is upward direction. Then the magnetic field is formed around the current carrying conductor anti-clockwise direction. In case of downward direction, the magnetic field is formed and the magnetic field lines are clockwise direction. This right hand thumb rule is also called Maxwell screw law, also known as Maxwell screw law. Corkscrew rule. So, according to the Maxwell corkscrew rule, imagine driving a corkscrew in the direction of current. Then the direction in which we turns its handle is the direction of magnetic field or magnetic field lines. So it is the corkscrew. When we driving a screw in a plant or whatever, we must rotate the corkscrew. So when this rotation of the corkscrew explains about magnetic field and in which direction the screw is moving. Is denote the direction of current, right? So when we rotate the screw in this direction, so downward or the clockwise direction. So while we are opening this screw, then you can take it like anti-clockwise, then it move up. Right? So right hand thumb rule says that imagine that you are grasping or holding the current carrying wire like this. So the thumb denotes the direction of electric current, and the fingers encircle denotes the magnetic field lines or the magnetic field. So the magnitude of magnetic field produced by a straight current carrying wire at a given point is directly proportional to the current passing the circuit and inversely proportional to the distance of the point from the wire. So how much magnetic field or the magnetic field strength depends on current passing in the wire, magnitude of current passing in the wire, and inversely proportional to the distance of the point from the wire. So more current is passing here, then current carrying produces magnetic field like this. So this magnetic field strength or the magnitude of magnetic field depends on how much current is passing through this conductor and the distance between the point and the field. Inversely proportional to the point. So, greater the current of wire, stronger will be the magnetic field produced, but weaker will be the magnetic field produced at the point. In fact, we move away from the current carrying wire straight wire, the concentric circles around the representing magnetic field lines become larger indicate the decreasing strength of magnetic field. So the size of the concentric circle is increases. The strength of the magnetic field is decreasing. So this is the center to distance between from center to the circle. The distance center and the circle increases. The strength of the magnetic field is decreases, and the more current is passing the current carrying wire, it produces strong magnetic field. So magnetic field is depends on amount of current or magnitude of current passing through the current carrying wire and distance between the center and the circle. Distance between the center and the circle. So finally, magnetic field is formed around the straight wire carrying conductor as a concentric circles. Concentric circles. So the direction of magnetic field is will understand by right hand thumb rule. Thumb direction of current, the encircled fingers are direction of magnetic. Upward direction anti-clockwise, downward direction clockwise. Then this right hand thumb rule also known as Maxwell corkscrew law. While we are moving the screw, so the direction in which direction we are moving, we know the direction of magnetic field and the magnetic field length. In which direction the screw is moving, we know the direction of current. So this is about magnetic field due to straight wire carrying current. So while it is current is carrying, there is some force also. Later we will discuss how much force is exerted. So this is about the field, or means the magnetic field formed by current carrying conductor. Right? Let us see some pictures. Current out of the page, current page, and then from old textbook I am showing you some pictures. So let us see. Magnetic field due to straight wire carrying conductor, and this is the arrangement of the experiment: stand, compass needle, wooden plank, conducting wire, switch, battery, table. Then current out of the page in the sense moving upward direction. See, the direction of magnetic field is anti-clockwise. Then current into the page in the sense, so direction of current is downward. In case of downward, you observe that the magnetic field lines are formed clockwise direction. Then the thumb, so I denotes here, the letter I denotes direction of electric current. Then the fingers are denote magnetic field. So current carrying upward and chupistunnam kabatti, then current carrying upward direction, then the magnetic field is anti-clockwise. If it is downward, and they are clockwise direction. This is about a magnetic field due to straight wire carrying conductor. So right hand thumb rule is also known as Maxwell corkscrew law. So in your textbook given definitions for all of the definitions given, thumb rule and Maxwell corkscrew rule. So you have to learn them and identify simply. Right? No need to by heart this, in which direction the magnetic field is formed, depending upon in which direction the current is flowing in a conductor. So thank you.